so continuing the problem from last time. Here's our function. In our last video, we took a look at the first derivative and saw where the function was increasing and decreasing, and also found that there was a min when x was 1 over 25. This time we're going to be taking a look at the second derivative. So f double prime of x is going to be negative 10 ninths x to the negative 4 thirds. Remember, each time I'm subtracting 1, I'm just subtracting 3 thirds. Okay. Let's see, plus, because I'm bringing down a negative, 4 ninths x to the negative 5 thirds. And again, I'm going to just rewrite that now that I want to do some algebra to see where it's 0 or undefined. I'm going to rewrite that in terms of some roots. So negative 10 over 9, that's the cube root of x to the 4th, plus 4 over 9 cube root of x to the 5th. Now, that's undefined at 0, which is no surprise at all. That's because the second derivative is the derivative of the first derivative. And the first derivative was undefined at 0. So, of course, the second derivative is as well. You can't take the derivative of something when it doesn't exist. Okay. So, this is a place where the second derivative might change sign as well. We don't have a fancy word for that. It's a possible location of a point of inflection, but we don't have a fancy word for it like critical number the way we do for the first derivative. Okay. So, I do need to look, though, at all the places where it could change sign, which includes 0 where it's undefined, and also any place that would make it 0. So I'm going to do the same thing I did last time. I'm just going to bump this term over so that I can cross multiply to get rid of the denominators. So 4 over 9 times the cube root of x to the 5th would equal 10 over 9 times the cube root of x to the 4th. I'm going to multiply both sides by 9 to just get rid of those 9's first, and then I can cross multiply, and that's going to give me 4 times the cube root of x to the 4th is equal to 10 times the cube root of x to the 5th. Okay, now that I've cleared denominators, let's go back to subtracting. 4 cube root of x to the 4th minus 10 cube root of x to the 5th equals 0. I can factor out a 2. And I can factor out the cube root of x to the 4th, the smaller power there. That's going to leave me with 2 minus 5 copies of the cube root of x, equaling 0. So if this factor is 0, that would be when x is 0. We've already determined that this is undefined there. So the only new point that I might get from this is if 2 minus 5 times the cube root of x is equal to 0, 2 would equal 5 times the cube root of x. The cube root of x would equal 2 fifths. And so x would just equal that cubed, which would be 8 over 125. Okay, so I can draw my number line now for f double prime. I'm going to mark off 0, and I'm going to mark off 8 over 125. Those are the two places that don't have a special name, but at which the second derivative could change sign. Oh, and I just erased it. Rats. I did not mean to erase my formula. So what was f double prime of x? It was negative 10 over 9 x to the negative 4 thirds. So cube root of x to the 4th plus 4 over 9 cube root of x to the 5th. Okay. That's messy. 9 cube root of x to the 5th. Okay. Now, I'm purposely putting my number line for f double prime under my number line for f prime. Because what we're going to do next is take a look at how they compare to each other, and particularly at what happens at that minimum value. Okay. So, I'm going to line up 0 with 0. And let's see, the other place was 8 over 125, which is to the right of 1 over 125. So I'm sort of lining things up. I'm not worrying about drawing things perfectly to scale, but getting things that are the same in the same place and bigger is to the right. Okay. All right, so I'm going to pick some test numbers. I like negative 1. If I plug in negative 1, let's see. F double prime at negative 1. It's going to be negative 10 over 9 just times 1, because the cube root of negative 1 is 1, but to the 4th power, it'll become positive 1, plus 4 over 9 times the cube root of negative 1 is negative 1, to the 5th makes it negative. So that's going to become a negative. So we're getting negative 14 over 9. That's going to be negative. Now, I'm going to put 2 negative signs there. There are 2 reasons for that. One is it helps me keep track of where I am in the process. I'm working with the second derivative, so I'm going to record the sign twice. Kind of dorky, but there you have it. Okay. The other reason is purely artistic, and I think that will become clear in a moment. Okay. So now, between 0 and 8 1 over 125, I need to plug something in. I'm actually going to just choose to plug in 1 over 125. Not usually a number I would pick, but it's easy to take the cube root of that because it's just 1/5. And that was my critical point up here. So we can kind of talk about that. Okay. So f double prime at 1 over 125 is going to be negative 10 over 9 times the cube root of this, we said was 1/5, and that's to the 4th, plus 4 over 9 times the cube root of that is 1/5, all, oops, to the 5th. Sorry. Okay. So that's going to be negative 10 over 9 times 5 to the 4th over 1 plus 4 over 9 times 5 to the 5th over 1. Now, I could work out 5 to the 4th. It's actually just 625 because it's 25 squared. 5 to the 5th is 625 times 5. I could work that out if I wanted to. I don't. So what I'm going to do is I'm going to factor out 5 to the 4th over 9, and I'm left with negative 10 plus 4 times just one more copy of 5, which would be 20. Oh, that's positive, and that's positive. This is going to be positive. Okay. So I can take some little shortcuts if I'm trying to figure out what some of the things are. Then for a number bigger than 8 1/25, I'm going to choose 1. That's the easiest number to plug in. If I plug in 1, since 1 to any power is 1, I'm just going to get f double prime of 1 is 10/3 minus 2/3. Yeah, 10/3 minus 2/3 is 8/3. And so it's positive there as well. So the second derivative doesn't actually... Oh, I'm sorry, I plugged into... My bad. Oh, I was looking at that, I plugged into that. I'm supposed to be plugging into the second derivative. So if I plug 1 into the second derivative, oh my goodness. I'm going to get negative 10/9 plus 4/9, which is negative 6/9, which is negative. Okay. It is entirely possible for a derivative to not change sign at a point. I wasn't expecting that with this particular function, so it does change sign at each of these points. So now, since this is the second derivative, that tells me about concavity. When the second derivative is negative, we're concave down, then up, and then down. And now I hope you can see the artistic reason I wanted to draw 2 plus or minus signs. They become the eyes of my smiley and frowny faces. Most exciting. All right, so let's write down the intervals on which our function is is concave up and concave down. We're going to be concave up between 0 and 8 over 125. All right, remember with concavity, it's always open intervals. We don't include the endpoints there. And we're going to be concave down from negative infinity to 0, union from 8 over 125 to infinity. Last thing, points of inflection. Points of inflection are going to be points, so they have an x and a y value, where the concavity changes. So I can see the concavity changed at 0, and if I want the y value of that point, I'm going to be plugging into the original function. So I'm going to get 0 minus 0, 0. So the origin is a point of inflection. And then I have another point whose x value is 8 over 125. And if I plug into this function, I'm going to just rewrite this in terms of roots. This is 5 times the cube root of x squared minus 2 times the cube root of x. And remember, the cube root of this was 2 over 5. So f of 8 over 125 is 5 times 2/5 squared minus 2 times 2/5. So that's 5 over 1 times 4/25 minus 4 over 5. That's going to cancel. Oh my goodness, is that 0 again? This is exciting. It is. Okay, so this is going to, one of the 5's is going to cancel, so it's just 4/5 minus 4/5, which is 0. So we're going to hit 0 at that location as well. So 2 points of inflection here and here.